going to look at another optimization technique, and this one's going to work for multivariable functions. And let's see what we have here. We want to develop a script to generate a contour and mesh subplot of the following temperature field. Okay. So you plug in the x and y coordinate for your location, and is what you get out is the corresponding temperature. Okay. All right. Well, the next thing we're going to do is we're going to pick our x values, and actually I'm not going to pick the entirety of our x values yet because I want to explain something. Let's say we said x equals 0 to 5, and we were going to just use 6 points in this vector. And let's say we were going to do the same thing with y. Okay. Well, I want to point out something. If we were to actually go in and just plug in these x, so if I were to use, like, say, the plot command, but let's say I was trying to, plot something in 3D. I want to explain what's going to be a little bit different here, right? In 2D, right, we would have just said x and y, and that would have been sufficient. And here, it's not going to be a whole lot different. We'll use surf, but it'll be x comma y, and then we'll have maybe big T here to represent the temperatures, okay? But this is actually not sufficient, okay? X comma y like this, okay? This is not sufficient because if we were to look at, say, the x and y values that we've just put in this vector, right, they are just 0, 1, 2, 3, 4, 5, and the thing is when you plug in x equals 0, you'd also like to plug in y equals 0, and when you let x be 0, you'd also like to plug in y equals 1, and when you let x equal 0, you'd also like to let y equal 2. So for x equals 0, you actually want to plug in all these y values, and for x equals 1, you want to plug in all these y values, and so on. And the reason why, if we were to switch to OneNote here, you can see I've made a little grid, right? When you plot something in 3D, you choose x's and y's, and the output is a z. Okay, and let me move this little timer here. Point is, if I were to, say, plug in x equals 1, I'd also have y equals 1, or y equals 2, or y equals 3, or y equals 4, or y equals 5. And I need to make sure that when I plug in x equals 1 that I hit all these y values that I care about as well. Okay? And then when I get to x equals 2, I need to do the same thing. I need to hit all these y values, okay, over that grid. So when you think about plotting something in 2D, you pick the x values, you just input it, and you get out the y's. Here, we need to plug in x's and y's. Okay? And again, it's going to create a grid rather than a number line. Okay, so next thing, question is, well, how do we create this grid? And it is like this. We're going to say big X, big Y is equal to mesh grid, little x, little y. Okay. I'm going to get rid of that. Okay, so this should actually get it done right here. Okay, and let's see what it does. Let's see what it does. Okay. So if I scoot this up, you can now see when x equals 0, y equals 0. When x equals 0 here, y equals 1. When x equals 0 here, y is equal to 2. When x equals 0 here, y is equal to 3. And so it's running through, for x equals 0, it's running through all the possible y's. Okay? And then it's going to do that for x equals 1, and then run through all the possible y's. And then x equals 2 and all the possible y's. Okay? All right, so next, I'm going to have surf x, y, and actually let's call it z. Keep it simple here. Okay. So we have big Z is equal to T of big X comma big Y, and we should probably also define T. Let's see here. So we have T equals at X comma Y, and let's see, we have 5 E, and then this is already vectorized. You can see I have the dot in here, which is good because we're going to actually plug a matrix in for X and a matrix in for Y. Okay, and that all looks good. Okay. So next, we could actually graph this and see what it looks like, except for I'm not confident that everything we want is between 0 and 5 in the X and 0 and 5 in the Y. So why don't we spread this out a little bit? Let's try minus 10 and minus 10 for the lower, positive 10 for the upper, and how about we'll do 100 points. Okay. All right, and how about we even add a little bit more? How about we add in here an X label, a Y label, and a Z label. So we have X label, and we'll just go ahead and we'll label it as X. Why not? And Y label. Let's make it Y. And then finally Z label. And let's go ahead and we will make that temperature. We don't know what any of the units are here, but you know, X and Y could be, say, in meters, and Z could be in degrees Celsius. Okay. But let's go ahead and plot this, see what we got. All right, it looks like we had a little bit of an error somewhere down there, but this is the graph we're looking for. But let's address the error down here. It just was up with our X label. I've just misspelt it. Okay, there we go. So if we're looking for, say, the maximum here, that'd be up here. Okay. And I do want to point out before I actually really focus in on the maximum, which is what we're going to be looking for here, we can move this around. So if you want to look at it from different angles, you can. But I want us to focus in on this max. So looks like it's happening close to X equals 2 and Y equals minus 3. So let's maybe adjust this so that we're looking at negative Y values, positive X values. Okay. So negative Y values, how about minus 5 to 0? And we said positive X, so how about 0? Oop. 0 to 5. Okay, and we will go ahead and run again. Okay, there it goes. And now it's a little bit easier to see that peak. And again, still looking really close to X equals 2, Y equals minus 3. Okay, and it looks like the maximum temperature is about pretty close to 5. Okay. But now the next question is, how do we find that? How do we find it? Okay. And there's actually another cool thing we can do before we truly find it, and that is we can look at the contour map of this. Okay. So I'm going to say contour of X comma Y comma Z. And I'm going to give this thing an X label. And actually, I'm going to give it the same X and Y label. Okay, the contour map's just going to be the level curves, but it might make it a little bit easier to see where this maximum is occurring. Okay. And I'm going to also add in here our subplot command so we can see these side by side. So how about we make a 1 by 2 grid, and we'll put this first one in the first location. And how about the contour subplot? and this is still going to be a 1x2 grid, but we'll put this contour in the second location. Let's go ahead and run. Okay. And so, again, these are the level curves. So the maximum should be right here in the middle. Okay. Right here in the middle. Okay. And that, again, that really looks like the middle of this is at 2 comma minus 3. Okay. Well, let's go ahead and verify this. Okay. Let's go ahead and verify this. Is what we're going to use to verify this is we are going to use fmin search to find the max. Actually, let's say use fmin search to find where the maximum temperature occurs. Okay. Well, the only thing I would change here, if we're going to be finding a minimum using something called, or a maximum using something called fmin search, is why don't we go ahead and multiply by a negative here so that instead we are finding a minimum, right? Let's go ahead and run it so we can see that. Okay. All right, so you can now see the maximum that we were trying to find is just a minimum, okay? Just by multiplying by -1. Okay. All right, so we have fmin search, and we'd want our function, which you would think that you could do, you know, t, and then you could do comma, and then you could maybe, you know, say what the x and the y coordinate are. Okay. Well, we have to be a little bit careful actually how we do this. Okay. I'm going to copy our function from up here, but I'm going to write it in maybe a different way. So when we're using fmin search, we have to kind of convince in some way that this is a single variable function. Okay? But when we do that, we don't genuinely mean it's one variable, okay? Because our one variable is going to actually be a vector. Okay? So x is a vector now. So I'm just going to call the first entry of the vector x1. And so everywhere I see an x, I'm just going to make this x1. Okay. And all the y's, I'm going to make those into x2s. Oop. There we go. So again, t is now just a function of x, but the first coordinate of x is the actual x value, and the second coordinate of x is the y value. Okay. All right. And here's the next thing. We would like to also provide a guess at what we think the root is. Okay. And why don't we call this temp? Okay. Just to change it so that we have a different function name for temp than we do for t up here. Okay. All right. And so we think that the root here, or I shouldn't say root, we think the minimum is occurring, you know, close to 2 comma minus 3. Well, that's actually what it's going to come out to be. So let's suppose that we were a little off here. Let's maybe say we did 2.5 and minus 4. Okay. And now let's try and use fmin search. Okay, so we have temp, and then we have x naught. And let's go ahead and run it and see if it gives us what we want, which is 2 comma minus 3. And I'm going to make sure I suppress everything up here. I have a bunch of stuff unsuppressed. And you can see it did give us the 2 comma minus 3, And if we want to see the temperature that corresponds to that, we could just say temp of, okay, of answer actually. And you see we get -5. Okay. Now remember though, we did find the correct x and y value for where this occurs, but since we had multiplied by -1, the maximum occurs at 5 is what it is. Okay. The maximum occurs at a temperature of 5, whatever those units might be. Okay. And the location though is at 2, -3. All right, and that is it